In the summer of 1950, four physicists were walking to lunch at Los Alamos National Laboratory. They were talking about flying saucers, the joke of the season, just a tabloid fad. The conversation drifted, the way smart conversations do, to something stranger, to the math of intelligent life in the universe, to how common it should be. They sat down, they ordered, and then one of them, Enrico Fermi, the man who built the world's first nuclear reactor, stopped mid-conversation, looked up, and asked a question so simple that it would haunt science for the next 75 years. Where, he asked, is everybody? The universe is 13.8 billion years old. It contains roughly 2 trillion galaxies. Each one holds, on average, 100 billion stars. And we now know, thanks to the Kepler mission and the James Webb Space Telescope, that almost every star has planets. By any reasonable estimate, the universe should be teeming with intelligent civilizations, billions of them. There has been more than enough time. There are more than enough worlds. And yet, when we look up, when we listen, when we point the most sensitive instruments humanity has ever built at the sky, we hear nothing. No signals, no transmissions, no visits, no ruins, just silence. Across 13 billion years of cosmic time. This is the Fermi Paradox, and the proposed explanations for it range from the merely strange to the genuinely terrifying. 11 years after Fermi asked his question, an astronomer named Frank Drake tried to formalize it. In 1961, at a small conference in Greenbank, West Virginia, Drake wrote on a chalkboard an equation that would define the search for extraterrestrial intelligence for the next 60 years. The Drake equation. N, the number of detectable civilizations in our galaxy, equals the rate of star formation, multiplied by the fraction of stars with planets, multiplied by the number of habitable planets per star, multiplied by the fraction where life develops, multiplied by the fraction where life becomes intelligent, multiplied by the fraction that develops detectable technology, multiplied by the length of time those civilizations broadcast. Plug in modern numbers, the ones we've actually measured, and the answer is staggering. Even with conservative assumptions, the Milky Way alone should contain somewhere between a few hundred and a few million detectable civilizations right now. The Drake equation isn't a prediction. It's a question framework, and the question it forces us to ask is this. If the math suggests the galaxy should be loud, why is it so quiet? Since 1960, we haven't just been guessing, we've been listening. Project Ozma in 1960, the SETI Institute since 1984, the Allen Telescope Array, the Breakthrough Listen Project, funded by Yuri Milner with $100 million in 2015. Together, these efforts have scanned millions of star systems across thousands of frequencies for tens of thousands of hours. They've found exactly one thing worth investigating. The WOW signal, detected in 1977 by Ohio State's Big Ear Telescope. A 72-second radio burst at almost exactly the frequency we'd expect an intentional transmission to use. It has never been explained, and it has never been repeated. One signal, in 70 years, lasting just over a minute. We have listened to billions of stars and heard, for all intents and purposes, nothing. So either intelligent civilizations are extraordinarily rare, or they exist, and we cannot find them. Each possibility opens a door, and what lies behind those doors changes everything. Here is the turn most people miss. The Fermi Paradox isn't really a question about aliens. It's a question about us. Because whatever is true of the rest of the universe, whatever explains the silence, is almost certainly true of our future too. And one of the proposed answers is the most disturbing idea in modern science. In 1996, economist Robin Hanson proposed an idea so unsettling that physicists still avoid discussing it in public. He called it the Great Filter. The Great Filter is a barrier, a step in the development of life so difficult, so catastrophic, that almost nothing survives it. Hanson argued that there must be one, because the universe should be loud, and it isn't. Something is stopping civilizations from reaching out. Something kills nearly all of them. The critical question, the one that determines everything, is where that filter sits on the timeline. Is it behind us, or is it ahead? If the filter is behind us, if the unlikely event was the emergence of complex cells or multicellular life or intelligence itself, then we are extraordinary. We made it through. The future may be ours. But if the filter is ahead of us, if something kills virtually every civilization before it spreads beyond its home world, then we haven't passed it yet. And here is what makes this theory genuinely terrifying. Finding microbial life on Mars, which would normally be cause for celebration, would be the worst news in human history, because it would mean life emerges easily, which means the filter isn't behind us. The silence of the universe may be the most reassuring thing about our situation. The second explanation comes not from a scientist, but from a novelist. Chinese science fiction author Liu Cixin, in his 2008 novel The Dark Forest, proposed an idea that has since been taken seriously by working physicists. The universe, Liu suggested, is a dark forest. Every civilization is a hunter, moving silently through the trees, and every hunter has independently arrived at the same conclusion. Any other intelligent life is a potential threat. You cannot know their intentions. You cannot predict their growth. You cannot trust their patience. The safest action, the only rational action, is to stay quiet. And if you detect another civilization, the safest response is to eliminate it before it can eliminate you. Under the dark forest hypothesis, civilizations don't go silent because they die naturally. They go silent because they learn. The ones that survive are the ones who realize, early, that the universe is not safe, and that the worst thing you can do is announce yourself. Researchers like Anders Sandberg at Oxford's Future of Humanity Institute have studied the dark forest seriously. They don't endorse it as truth, but they cannot rule it out. Which raises an uncomfortable question. We have been broadcasting our existence into the cosmos for over a century. Every radio transmission, every television signal, every burst of radar. If the dark forest is real, we may have already made the only mistake that matters. A gentler explanation was proposed in 1973 by MIT astronomer John Ball. He called it the zoo hypothesis. The zoo hypothesis suggests that advanced civilizations do exist, many of them, but they have agreed, deliberately, not to interfere with developing species. We are being observed, we are being protected perhaps, but we are not being contacted, not yet. Not until we are ready. Why? Perhaps the introduction of advanced technology would collapse our development, the way contact has collapsed nearly every isolated culture in our own history. Perhaps they are waiting for us to ask the right question. Perhaps they are waiting for us to stop killing each other. The zoo hypothesis is impossible to disprove, which is precisely the criticism leveled against it. But it has one feature the darker theories lack. It allows the universe to be quiet without requiring the universe to be hostile. The fourth major explanation reframes the question entirely. Maybe the math of the Drake equation is wrong, not in its structure, but in the assumptions we plug into it. The rare Earth hypothesis, developed by paleontologist Peter Ward and astronomer Donald Brownlee at the University of Washington in 2000, argues that intelligent life requires an extraordinary number of unlikely conditions. Conditions Earth happens to have, and almost no other world does. A stable star that doesn't flare too violently. A magnetic field strong enough to protect the atmosphere from solar radiation. Plate tectonics to recycle carbon. A large moon to stabilize the planet's tilt, the right position in the galaxy, far enough from the center to avoid catastrophic radiation, close enough to have heavy elements, Jupiter in the outer solar system, sweeping away comets that would otherwise wipe out life every few million years. Under rare Earth, the universe is silent, because intelligence is genuinely rare. We are not the first, we are not the only, but we may be among the very, very few. Perhaps the only ones in this corner of the galaxy. Perhaps the only ones in this galaxy at all. Among working scientists, there is no consensus on which explanation is correct. There may never be one. But the question itself has shifted in the last decade from philosophy back into science. Harvard astronomer Avi Loeb, former chair of the astronomy department, has argued that we have been too cautious in our search. In 2017, when the interstellar object Oumuamua passed through our solar system, Loeb proposed, controversially, that some of its strange features might be best explained as artificial. He has since founded the Galileo Project, a serious scientific effort to search for evidence of extraterrestrial technology. The James Webb Space Telescope, launched in 2021, can now analyze the atmospheres of distant exoplanets for biosignatures, chemical markers of life. For the first time, we are not just listening, we are looking. Breakthrough. Listen continues its survey. Frank Drake, who started it all, passed away in 2022. His equation remains unsolved. The variables we've measured suggest the universe should be alive. The variables we haven't measured will determine which of these theories is correct. We are, right now, in the earliest minutes of an investigation that may take centuries to resolve. The Fermi Paradox forces every thinking person to confront a single question. If the universe should be loud, and it isn't, what does that tell us about our own future? Are we early, the first intelligent species in our galaxy, looking out at a cosmos that hasn't had time to wake up yet? Are we late, the survivors of a great extinction we don't yet understand? Are we alone in a way that's mathematically improbable? Or alone in a way that's been deliberately engineered by something that doesn't want us to know we're being watched? Each possibility carries weight. Each one shapes how we should act, what we should build, what we should broadcast, and what we should keep quiet. The universe is silent, but the silence is not empty. It contains an answer. We are simply not yet equipped to hear it. 75 years ago, in a New Mexico cafeteria, Enrico Fermi asked where everybody was. The question has outlived him. It will likely outlive us. But somewhere, in our lifetime, or the one after, we may receive the answer. And whether that answer is a signal, a silence, or a discovery on the Martian surface, it will be the most important thing humanity has ever learned about itself. The universe should be loud, and it isn't. Until we know why, every theory remains possible, and every one of them matters. What do you think is out there, and why haven't they found us yet?